Ever wondered what keeps galaxies from ripping themselves apart? There's something massive out there we can't see. Dark matter. It's the universe's biggest unsolved mystery, and today we're going hunting for this invisible cosmic glue. Back in the 1930s, astronomer Fritz Zwicky noticed something bizarre about the Coma galaxy cluster. It was spinning way too fast. According to our physics calculations, these galaxies should have been flying apart like a cosmic game of marbles. But they weren't. They stuck together, like there was some invisible force holding them in place. Zwicky called this mystery the missing mass problem. Think of it like watching a merry-go-round spinning so fast that the horses should go flying off. But somehow, they stay put. That's exactly what was happening with these galaxies, and it drove scientists absolutely crazy trying to figure out why. This weird discovery kicked off one of the biggest cosmic treasure hunts in history. Here's the wild thing about dark matter. It's basically playing the universe's longest game of hide and seek. We can't see it, touch it, or detect it with any of our fancy equipment. But we know it's there because of how it messes with everything around it. Imagine you're at a party and someone keeps moving your drink when you're not looking. You can't see the prankster, but you know they exist because your drink keeps changing spots. That's exactly how dark matter works. It doesn't interact with light or regular matter, but we can track its presence by watching how it pushes and pulls on stars and galaxies. The math tells us this invisible stuff makes up about 85% of all matter in the universe. Pretty mind-blowing, right? Think of a galaxy like a giant cosmic dance floor. Stars are the dancers spinning around the center, but here's the thing, they're moving way too fast. By all rights, these stellar dancers should be flinging themselves right off the dance floor and into space. But they don't. Why? Dark matter acts like an invisible dance instructor, its gravitational pull keeping everything in perfect rhythm. Without this cosmic choreographer, our own Milky Way would have torn itself apart billions of years ago. The stars at the edge of our galaxy are moving at about 200 kilometers per second. That's over 400,000 miles per hour. Yet they stay in their orbits, held there by dark matter's ghostly embrace. Let me tell you about the most epic cosmic car crash ever, the Bullet Cluster. Back in 2006, astronomers spotted something amazing. Two massive galaxy clusters that had smashed right through each other. Here's where it gets weird. The regular matter, all the stars and hot gas, got tangled up and slowed down in the middle like a giant space pileup. But the gravity kept moving straight through as if nothing happened. This was our smoking gun. Solid proof that most of the mass in these clusters wasn't in the visible stuff at all. It was dark matter, ghosting right through the collision like it wasn't even there. This discovery was huge. It's basically the closest we've come to catching dark matter in the act. Scientists have tried some seriously creative ways to catch dark matter, and I mean seriously creative. We've built detectors deep underground in abandoned gold mines, set up supercooled crystals that would shatter at the slightest touch from a dark matter particle, and even launched specialized satellites into space. My favorite has to be Xenon, this massive tank filled with ultra-pure liquid xenon, sitting in a mountain under Italy. It's like the world's fanciest ghost trap. The idea is that if dark matter hits the xenon atoms, we'll see a tiny flash of light. So far, nothing. Zilch. Zero. But that's science for you. Sometimes the most exciting discoveries come from years of finding absolutely nothing. These experiments might seem like failures, but each one tells us something new about what dark matter isn't. So here's where things get really interesting. What if we've been wrong about dark matter this whole time? Some scientists think we don't need invisible matter at all. Maybe gravity just works differently than we thought. This idea is called modified gravity, and it sparked some heated debates in physics circles. Think of it like this. If you see a car moving without an engine, you might assume there's an invisible engine. But what if the rules of how cars move are just different than we thought? Both ideas sound pretty wild, right? But here's the kicker. The bullet cluster we talked about earlier makes modified gravity really hard to explain. It's like catching your car moving uphill by itself. Let me blow your mind with this. Dark matter built the universe's skeleton before regular matter even showed up. Think of the early universe like a giant construction site. Dark matter clumped together first, creating a massive web of gravitational wells. Then regular matter, the stuff that makes up stars and planets, just followed these cosmic blueprints like water flowing into valleys. This dark matter framework is why our universe looks like a gigantic spiderweb, with galaxies clustering along invisible threads and collecting at the intersections. Without this shadowy architect, we wouldn't have the beautiful cosmic neighborhoods we see today. It's like dark matter drew the map, and everything else just filled in the lines. Ready for dark matter's greatest hits? This stuff might be invisible, but it sure knows how to put on a show. It bends light like a cosmic funhouse mirror. We call this gravitational lensing. Imagine looking at a distant galaxy, but dark matter's massive gravity warps space so much it creates multiple images of that same galaxy. It's like nature's own Instagram filter, but that's not all. Dark matter can create massive walls in space, corralling galaxies into massive superclusters. And get this, it even slows down time. Anywhere there's a big chunk of dark matter, time actually flows slightly slower, thanks to Einstein's rules about gravity and space-time. Talk about being fashionably late to the cosmic party. Ready for the ultimate cosmic plot twist? Dark matter isn't the only invisible force messing with our universe. There's also dark energy. While dark matter pulls things together like a cosmic magnet, dark energy does the exact opposite. It pushes everything apart. Imagine playing tug of war, but one team, dark matter, is trying to keep the universe cozy and close, while the other team, dark energy, is determined to stretch everything into infinity. The weird part, dark energy is winning. Our universe isn't just expanding, it's speeding up. Together, these invisible forces make up 95% of everything that exists. That means all the stars, planets, and galaxies we can see are just the tip of the cosmic iceberg. Want to know what's next in our cosmic ghost hunt? Scientists are cooking up some mind-blowing new experiments. We're talking about detectors the size of office buildings filled with liquid xenon, super powerful telescopes that can map dark matter across billions of light years, and even using quantum sensors that can pick up the tiniest gravitational ripples. My personal favorite? The Darwin Project. Imagine a tank holding 40 tons of the purest xenon ever made, cooled to near absolute zero. It's like building a giant cosmic mousetrap. If a dark matter particle even whispers near this thing, we'll catch it. These next-gen experiments might finally help us crack this invisible cosmic puzzle. And that's our journey through the dark side of the universe. Pretty wild stuff, right? If you enjoyed this cosmic adventure, smash that like button and subscribe for more mind-bending science. Share with a friend who loves space mysteries. See you next time.